10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Hello everyone. You are watching Chemistry TV with me, Miss Dee. SM candidates, are you ready? So class, what are we gonna learn today?
Miss Dee, can you help me?
What happened to your shirt?
This is my favorite shirts. My favorite shirts are dirty. Can you help me to clean it?
Yes, I will help you to clean it with my superpower.
Wow!
So class, what are we going to learn today is about chemical for consumer, and I will focus more on soap and detergent. Before we proceed, this is the learning outcome. First, to state what is soap and detergent is all about. Second, to describe the preparation of soap and detergent. And third one is to describe the cleansing actions of soap and detergent. And the last one is to compare and contrast the effectiveness of soap and detergent. So guys, what is soap? Soap is a salt. It is formed from a neutralization reaction between fatty acid and alkali. One example of soap is sodium palmitate. Sodium palmitate is formed from a reaction between sodium hydroxide and also palmitic acid. Next, what is detergent? Detergent is formed from a neutralizing reaction between alkyl hydrogen sulfate with alkali. One example of detergent is sodium lauryl sulfate. The detergent that we use at home contain many additives. For example of additive is biological enzyme and whitening agent.
Saponification, the process of making soap. First, we need measuring cylinder, 15 gram of common salt, glass beaker, coconut oil, 20% sodium hydroxide solution, Bunsen burner and filter funnel. Measure 25 ml of coconut oil into a measuring cylinder. Pour the oil into the glass beaker. Take another measuring cylinder and measure 30 ml of 20% of sodium hydroxide solution. Pour it into the glass beaker containing coconut oil. Stir the mixture vigorously using glass rod. Touch the beaker from outside. You will observe that the beaker is warm. This is due to the oxothermic reaction between vegetable oil and NaOH solution. Place the beaker on the Bunsen burner and heat it until the beaker forms a whitish phase. The mixture is made up of soap in suspension, foam, and glycerol. Remove the beaker and allow it to cool. Dip a red litmus paper and it will change to blue color. This shows that the soap solution is basic in nature. Dip the blue color litmus paper. The blue color remains the same. This shows that soap suspension is not acidic in nature. Add 15 gram of common salt into the suspension. Stir it well with the glass rod. It is observed that the soap is precipitated out as a solid. Take a filter paper and fix it in filter funnel and hold the glass rod over the funnel. Take the beaker containing soap and pour it over the glass rod and filter the mixture. Soap is left on the filter paper. Take the filter paper and remove soap from the funnel using a spatula and place it into the filter paper. Dry the soap by pressing it using another filter paper. Cut it into the desired shape with a knife and soap is thus prepared. Cleansing action of soap and detergent. Have you ever tried mixing oil and water? Oil and water are immiscible liquid. If oil and water are mixed together, oil separates and forms a layer of its own. Oil floats on water as it less than the water. Why don't oil and water mix? Water molecules are bipolar molecules. They form strong electrostatic bond with each other. Oil molecules, on the other hand, are non-polar and not make bond with a polar water molecule. The bond that hold oil molecules are weak van der Waals forces. Observe that oil molecules are large as compared to water molecules. For the mixing of any two liquids, their molecule must have similar nature. Since their molecules are not similar, water and oil do not mix. Molecules that carry charge are attached to water and are called hydrophilic or water-loving, while molecules without charge lack affinity for water. They are known as hydrophobic. Oil is a hydrophobic liquid. If a mixture of oil and water is agitated vigorously for a sufficient period of time, the emulsion consists of minute droplets of oil dispersed in water. What happens if this emulsion is allowed to settle down? The oil droplets slowly coalesce and form a separate layer, as we can infer that the oil and water emulsion is not a stable system. Let's add some soap or detergent to the mixture and see the magic. The addition of a little soap of detergent before agitating the mixture helps in the formation of stable emulsion. The soap or detergent act as a surfactant or emulsifier. The surfactant molecule surround the oil droplet and prevent them from coalescing. The cleansing action of soap and detergent is due to their power to emulsify oil. Come, let's learn the cleansing action of soap and detergent in this module. At the end of this module, you will be able to describe the cleansing action of soap and detergent. Soap and detergent are surfactants which help to dislodge dirt and grease by emulsifying them and thus help clean articles. Let's take a look at the molecular structure of soap and detergent. Observe that they have similar structure. Each molecule is composed of a long non-polar hydrocarbon chain which is hydrophobic in nature and a short polar head which is hydrophilic in nature. The hydrophilic end is attracted by water molecule, whereas the hydrophobic end of the molecule is repelled by water, but it is attracted by non-polar substance like oil. The cleaning action of detergent and soap is attributed to this special feature. Have you ever wondered how soap and detergent work to get rid of dirt? Here, how dirt or grime generally has an oily component. Water cannot dissolve oil, and hence water by itself cannot take away dirt. This is where soap or detergent come of use. Dirty clothes are soaked in water containing soap or detergent. When detergent or soap molecule come in contact with the oil or dirt on the fabric, a micelle is a bowl-shaped collection of detergent or soap molecule with the hydrocarbon end clumped together on the inside and the polar head on the outside. Eventually, through either agitation or stirring of water or rubbing, these micelles are lifted off from the fabric surface and get into the washing machine. Remember that because of the charge on the head of detergent molecule, the outer space of the micelle is charged. Since these micelles all have similar charge, they repel each other and remain suspended in water. These get removed when the water is drained off. Repeated rinsing and wringing remove all such micelle and make laundry crispy clean. So what is the difference between soap and detergent? There are 5 properties of soap and detergent. First, the cleaning power. Second, ease of rinsing. Third, pH. Fourth, molecular structure. And fifth, the formation of scum. In terms of cleaning power, detergent is more powerful than soap. Next property is ease of rinsing. Detergents rinse out well from clothes. Another property is soap is slightly alkaline. For the molecular structure, soap is determined by the structure of fatty acid found in the oil or fat used to produce soap. And for detergent, it can be modified to suit the cleaning task. For the formation of scum, soap forms scum with hard water. Scum is a layer of dirt on the surface of a liquid.
Dua, tiga.
So, have you guys understand what is soap and detergent? Thank you for watching Chemistry TV with Miss Dee. So, I would like to thank you to my superpower and to my student and to my photographer. Thank you. Bye.
Dah.
Buka suit butter lagi. Buka helmet lagi. Okay. Satu.
1, 2, 3.
Thank you for watching.
Belum belakang lagi.
Harus dari belakang, dari belakang. Tinggi sangat. Ha.
Sini gerak, dia lupa tolong tak?
Tengok cantik lah tengok.
Power.